Good morning, everyone. Okay, good morning. I would like to welcome the 15 participants that we have so far for this fifth and the last webinar for this series as we celebrate the 109th CEAT founding anniversary with the theme Future Proofing Communities Through Engineering Innovations. So today's webinar will be hosted by the Institute of Agricultural Engineering. And my name is John P. Foliente. I will be your moderator for today's webinar. So without further ado, we will now proceed to the opening remarks. And since Sir Luyan has been in a meeting Sir Luyan is there already. Okay, for the opening remarks, I would like to call on Dr. Roger A. Luyan Jr., the OIC Director of the Institute of Agricultural Engineering, to formally open this webinar. Sir?
Thank you. Good morning, everyone. I would like to welcome you to this fifth and last edition of our webinar series to celebrate the 109th anniversary of CEAT. So it is fitting that we end this webinar series with a presentation from the Institute of Agricultural Engineering, since the college traces its roots from the Department of Agriculture under the College of Agriculture way back then, 109 years ago. So it was developed into the Institute of Agricultural Engineering and Technology, and then later on elevated into the College of Engineering and Agro-Industrial Technology. So now it has come full circle, no? From being a major under the BSA program. Now we have before we have the BS Agricultural Engineering, and now we have the BS Agricultural and Biosystems Engineering program. So, so it has come full circle, as I have said, now from providing engineering solutions to problems in agrometeorology, farm structures, irrigation and drainage, uh, farm machinery, rural electrification, and crop processing. We are now applying innovations and current technologies, uh, like, for example, controlled environment, remote sensing, smart irrigation, precision agriculture, uh, dynamic sensors, no? Automation, robotics, and among others. Okay. So, of course, to illustrate all of these innovations and current technologies, uh, we have as our presenter for today, Assistant Professor and Engineer Fidelina Flores. And I hope with his topic, non-destructive prediction of paddy seed quality using NIR spectroscopy, that we will learn more of these new technologies that we are currently applying, so to improve our agriculture. So, and also, of course, this is some sort of a come on to youth and women participation in our agriculture modernizations. And without further ado, again, welcome to this fifth webinar series, and I hope we learn much from this. Thank you very much.
Okay, thank you, Sir Roger, for giving our audience an overview of what we've been doing here in the Institute of Agricultural Engineering. And as we have mentioned as well, the topic for today will be the non-destructive prediction of seed quality using NIR spectroscopy. So our presenter for today took both her BS and MS in agricultural engineering here in the university with the following specialization: agriculture and power machinery engineering and post-harvest horticulture respectively. And she's currently a faculty at the Agricultural and Bioprocess Division. Let's welcome Professor Fidelina T. Flores.
Thank you very much, Joanne. Can everyone hear me?
Yes, ma'am.
Okay, thank you. Allow me to share my screen, please. Can I share my screen? I think you have to stop. Yeah, that's good. Before I start, can everyone see the title slide? Can I really check it now?
Yes, ma'am. It's already
Okay, thank you
presented.
very much. So thank you very much for that introduction, Joanne, and also for the opening message, Dr. Luyan. So once again, good morning, everyone, and I am here to present our study on the non-destructive prediction of paddy seed using NIR spectroscopy. Quality of planting materials is very important as it contributes to the production of cost of crops. And then this shows that seed quality parameters must be high enough for farmers to recover their initial cost. The standard method of quality measurement of paddy seeds is usually time consuming because the test must be conducted for a few days before you could have your result. Say, for example, you have to wait for 5 to 7 days. And also, some important seed quality parameters that breeders monitor are seed germination and seed vigor. Germination test is done to determine the percentage of the seeds that are still alive in a given seed lot. Now, this germination rate together with the data on seed vigor provides a measure of the potential of the crop in the field as it dictates the um, suitability of the seeds for planting. Take note that this principle is that the viable seeds that germinate should be able to absorb moisture within uh, a number of days, 2 days, for example, and then also produce a root and a shoot at the first leaf within 4 days. And then uh, breeders and traders usually they face this challenge in identifying the seed lots that must be marketed for the current season, what must be uh, sold to the farmers, and then also if the seed quality, for example, is still high enough, they then it is can still be stored in their storage. Now, there is a need to use a rapid method to determine the seed quality to help farmers and traders save time and cost during the planting stage. Doing this or having this need for the having the rapid method, NIRS then or the near infrared spectroscopy can help in checking this crop quality based on standard methods that could further improve the process and operation as you will not be waiting for a number of days. So take note that this technology is not new at, as it has been used for a number of crops, a number of times in the industry to predict quality parameters of various agricultural materials. Now, our sample on this study is paddy. Now, paddy as an agricultural material, usually these undergo the process of aging, in which when it ages, it decreases the germination rate. Also, it comes with the vigor. Now, paddy seeds have germination rate as high, or could the germination rate could go as high as 80 to 90%. Now, especially when it is freshly harvested. Now, when you store the seeds, the germination rate deteriorates and also the seed viability. Take note that after drying, paddy seeds are stored in our process. After you dry, you store it, or you either you store it as a planting material or you mill it for consumption as meal. Now, the length of storage of paddy seeds affect the water content in the seed, the sugar, proteins, and also lipids. Some property changes or the effect of these changes include tasting properties in your meal dries, for example, color, flavor, and other physical and chemical changes. Now, That is why some people have this, you try to smell the milled rice when you buy it on the market. Now, the control of moisture content when you store your seeds is very important in maintaining this seed quality parameter. Now, the near infrared spectroscopy is a known rapid and non-destructive method of determining physical and chemical parameters of material. This one measures absorption bands of biological materials in the electromagnetic spectrum from 780 nanometers to 2,500 nanometers. These work in the principle that NIR light hit a sample and then this could be reflected. The light that passes through the sample could be reflected, absorbed, or transmitted. And then this amount of light, when apportioned to each phenomenon, is a function of the chemical makeup and physical structure of the material. So depending on the component or the characteristics of the material, it will have a different measure, or it will have a different manner on how it will reflect, how it will absorb, and how it will transmit the light. NIR uses also vibrational behavior of molecular bonds like the hydrogen bond in biological materials. Other molecular bonds containing hydrogen are OH, CH, CO, and NH, and then also SH bonds. So these bonds are what we're trying to locate into our materials and how the light will, or the component of these molecular bonds on that material, it will have a different configuration on how the light will be reflected, absorbed, or transmitted. Now, together with this one, we have to analyze the spectral data using appropriate statistical methods through chemometrics. Take note that the properties of the materials is predicted by, we have to relate this spectral data, so the one that we were able to measure, the reflectance, absorbance, or the transmittance, we will be relating that property or that measure into a known reference standard. So take note that we will still be using reference standards, or we will still be using our reference methods on determining the quality of our crops. Now, the study generally aims to develop calibration models using NIR spectroscopy and discriminate rice seeds according to germination rate and vigor. And once you have this calibration model, we aim, of course, have to validate these models. Now, how does our experimental or our laboratory setup looks like? So the data acquisition and scanning was done in the laboratory at the IAE, and then SpectraSuite uh, program or software was used to measure the reflectance. We are working on the reflectance mode in our setup. And then each paddy seedlet was scanned at 5 random points. So you have one Petri dish. It will be, so this one, letter E on the, as you can see on your slide on the optic probe, this is where we have the sample. So on the next slide, later on you will see how I did the random, uh, determining the 5 random points. Now, so each paddy seedlet was scanned at 5 random points, and then the fiber optic probe at letter E is Ocean Optics brand was mounted perpendicular to the sample to obtain our reflectance spectra. And then we use two spectrometers, the NIR Quest that works at 900 to 1,700 nanometers, and then USB at 300 to 1,000 nanometers. So we measure this data side by side. So after NIR Quest, we use the USB 4000 spectrometer. Light source we use is a tungsten halogen that works at the range of 360 nanometers to 2,400 nanometers. So on this uh, on this data, so as you can see the fiber optic probe, the white circles on the outside portion of your fiber optic probe, this one is coming from your light source. So it's where the light coming from, and then it will it will be the one that will have contact with your samples, and then the reflected light will be measured by the red dot here. So the red dot is connected to your spectrometer. Take note that this one, the color is not really is all only, sorry, for illustration purposes only, so that you will see where the light comes in and then where the light is being reflected. Now, for the flow chart of the uh, data, so wait. So immediately after scanning the two spectrometers, the seed samples were sent to the laboratory so that we could do the standard method for determining the germination rate and vigor of the seed samples. So after this one, seed vigor was computed as the percentage of the germinated seeds after 5 days. So if you see sprouts or or some roots on your seeds after 5 days, so you count how many seeds exhibited that kind of uh, manifestation, and then you count another 2 days. Then you again count the number of seeds. You now measure your germination rate. Now, spectral data were then divided into calibration and prediction sets using a ratio of 2:1. The acquired NIR spectra were subjected to data pre-processing by mean centering, data pre-processing and transformation. Techniques used is mean centering and then mean scatter correction. So we use R Studio or R software to reduce the effect of light scattering, to do the data noise and peak valley overlap. These data pre-processing techniques are used to eliminate irrelevant information and so as improve the data analysis before we do the multivariate analysis. So mean centering is the first pre-processing technique we did, as it guarantees that the result will consider only the variation within the mean and is recommended for all data types. The MSC, or the mean scatter correction, is a normalization technique to remove further effects of light scattering and uh, linearizing its spectrum. Now, after the data pre-processing and transformation method, we do the principal component analysis and partial least squares to the new set of variables, and then we try to model this one. We have the calibration model and then the prediction model. So these two models, the method of accuracy, the model accuracy measurement we have is through the coefficient of determination and then the root mean square error. Now, if you want to further analyze your data, you could determine the useful wavelength. Then you just have to plot a number of results from the PCA versus the wavelength for you to identify the useful wavelength. The calibration models were then validated using the prediction set. So take note that the calibration set was used to make the calibration model. So once you have the calibration model, you use your validation set to test the performance of your calibration model. So that performance, if you already use the validation set, then that performance would then be reflected into your prediction model. Now, seed samples, the one that we use in this study, were classified into 4 groups. So we categorize it into 4: very high, high, moderate, and then low germination rate. So high, greater than 90%. Very high is greater than 90%. High, 80 to 89. Moderate is 70 to 79, and anything below 70 would be considered low. Now, this one is how we did the scanning. So this one the one inside the yellow box, sorry, it was cropped. So this one is the fiber optic probe. So it has a distance. It's not really directly in contact with the body seat. So there's a certain height that we try to maintain all throughout the experiment. So this one is a black body so that no other noise or light would be absorbed by the samples during the data scanning. Now, this figure shows the raw spectral data of the reflectance values of the seed sample. Now, the plots were divided according to this one into four groups. So you have the low germination, high, very high, and then the moderate germination. Now, if we are to superimpose one, so the four graph, for example, low plus moderate plus high plus very high, it will be quite very difficult for us to see which is which seed would have this certain low germination rate, which seed belong to the high germination rate. So it was quite uh, a challenge or difficult for us to easily identify that one. That's why we have to do the multivariate analysis. So this one, the figure, sorry, the figure on A is using the USB 4000, and then this one, figure B, is using the NIR quest. So after data pre-processing, PCA, or the principal component analysis, and partial least square regression was done in the pre-processed data. So this is the three figures on the up is your calibration models, and then the figure on the bottom are your prediction models. So this one is on the visible region. So this one is under the USB 4000 spectrometer. Now so this is a plot of the observed germination. Here, these values are the one that you get when you do the standard method of determining the seed quality parameters. The prediction on the y-axis, these are your prediction or predicted parameters. So this one is the predicted value using the calibration model. Okay. Now, same with this one, but this one is same model, but your samples would be using the prediction set. Okay. Uh, Remember, at the start of the development of your calibration model, you divided your data. You have the calibration set, you have the prediction set. Okay. Now, for the performance of the model using your uh, uh, near infrared vision, so it's this one is your calibration model, and then this one is your prediction model. The performance of models both for the two spectrometer is shown on this table. Take note that the parameter used to evaluate the performance of the model is R squared and then also root mean squared. We also have this mean absolute error. Our results using the NIR quest under the 900 to 1, it should be 1,700, sorry. 900 to 1,700 nanometers shows that a calibration model for the seed class, so this one is 0.8, and then this one is 0.7, I think. Yeah, 0.6. Has a higher value compared to the other two parameters, which are germination rate and then seed vigor. Comparing the seed vigor with the germination rate, the models uh, developed the models developed for the germination rate performed better compared to the seed vigor. Okay. Now, this only shows that the two quantitative the sorry, the qualitative parameter, which is seed class, performed better over the two quantitative parameters between germination rate and seed vigor. It only shows that the models that we developed were able to easily classify seeds based on their level, or on the range of their germination rate, rather than identifying or pinpointing the exact value of their seed quality parameters. So the results, or these results, can then be used as a basis in designing a portable NIR instrument that could further serve as on-site screening to easily identify the seed class of the samples. Take note that though we have the lower R squared value for the quantitative models, we were still able to predict the seed quality parameters. So based on the RMSE values and using the guidelines according to Williams and Norris, the model can be used with caution. Take note that it is with caution in most screening applications like in research. So some, as you can see, I don't know if you take note that the level of germination rate that we use for the sample could go as low as below 20. Okay. And then the range for the moderate to high to moderate, they only have 10, uh, 90 to 10, they only have a 10 difference. 70 below, that's quite a higher number or higher difference, all falls below the low level of germination rate. So the distribution of samples might have an effect on the performance of the models that we have for this study. Now, studies on soybean show that the qualitative prediction of germination rate together with vigor was possible using the two category model. So they only use the low and then high category. And then the quantitative prediction of germination rate was less accurate. Their R squared value is 0.45. Study almost the same with this one since they use paddy seeds. They have this point where a correlation coefficient of 0.93, but the samples that they use ranges only from 65 to 90%. Okay? And then another one use tomato seeds. They are classifying tomato seeds non-viable and viable tomato seeds, and were able to identify useful wavelength at 1,336 nanometers to 1,665 nanometers. So this wavelength, according to them, is associated with the fatty acids that showed a positive relationship with the that affects the viability of seeds. So it has that certain component of the protein or the moisture that affects or that could easily classify, could help in easily classifying the seed. As a summary, so we were able to develop NIR models, and then the NIR model prediction models were, yeah, for seed vigor and seed germination rate. Together, we were also able to classify seeds based on their level of germination rate. Also, the quantitative and qualitative models was capable of predicting seed quality parameters like vigor and then the germination rate. The NIR spectra of paddy seeds can be used to classify them according to their level of seed germination. And then this rapid method can be used to complement laboratory testing, side-by-side laboratory testing, when we will be needing, on when the farmers or the traders and breeders will be needing a quick seed quality profiling, or they have to do uh, fast or make fast decision in the field. So some recommendation and future activities that could still be done. So we will you'd like to scan more samples to further strengthen the model. Take note that we only use 71 seed lot sample on this study. We just multiplied it by 5 so that we'll have more spectral data. And then also, since rice ages during storage, maybe you could also classify seed samples based on the storage duration. So which seed is stored for 1 month, which seed is already been or has already been stored for 3 months, 4 months, or 5 months. You could also try to study predict where the seed um, was planted. If you could do that one. There are studies that they could trace whether the commodity is organic or not. So if they could do that one, probably they could also try doing or determining the planting location of your seed sample. You could also try doing other data pre-processing and transformation or further multivariate analysis. And then this last one is you could try to perform reducing seed class into two, so pass or fail. Or if you had that certain level, say for example 80, if it's 80 below, it will fail. If it's 80 above, it will pass. So if you could have that magic number, then reanalyze the data, then you could check the performance of your model. Or you could also do adding or having three classes, so low, medium, or high. Okay. So I think that would be all. I'd like to thank Parfi and also USDA for providing us funding and also letting us use their spectrometers for this study.
Thank you, Ma'am Fide. We will go ahead and take some time for questions now. Again, a reminder, if you have question, please type it into the chat box in your control panel. So we have two questions so far. The first question is, apart from rice or paddy seeds quality assessment, are there any research work in abroad where NIR spectroscopy technology is being applied?
That's a very nice question. Thank you very much. So currently there are studies, and then their sample is sugar cane, and then there are all research of the students uses pineapples. As pineapples, they are determining physicochemical parameters like uh, TSS, PA or pH, and then starch content of cassava and color for tomato and maturity index or fruit color index taste, I think, of mango. So you could, there are really many other samples being, I mean, studies done by the students, or you could try other crops if you like.
Okay, thank you, Ma'am. The next question is, with regards to the accuracy of the methods you're using in NIR analysis, what are the things you're doing to improve its accuracy or how it can predict?
Thank you very much also for that. Currently, we're trying to do other data pre-processing, same set of data, but we're trying to do the SNB data pre-processing. We also try to remove, if you remember on one slide, they tried the range of their sample is only 60 to 95, I think. We're trying to cut down the data, but then we will lose some data if that will happen, or data samples. That could be done, and then you again remodel your, uh, you do the data analysis for you to get your calibration and new calibration model. So you could either cut down the data so that there would be a smaller difference on the low level of germination rate, or you or could try other data pre-processing techniques. Or sorry, last. You could also add more data because this is only a population of 71 seedlot sample. Maybe if you could add more samples to the spectral library, it will perform better.
Okay, we have another question. Do you have any recommendations for an instrument that can be used in the field? Because what you're doing is in the laboratory.
That's
Okay.
a nice one. Currently, there are already portable NIR instrument available. If you try to check on the internet, can I say, there is a one manufacturer that you could buy as a palm size portable spectrometer. It works same range with NIR Quest 900 to 1700 nanometers. We have that one, and then we're current on the next phase, we're trying to calibrate that portable NIR instrument with the data that we have on year one. So there are portable NIR instruments available already in the field. Some some companies have that uh, NIR scanner that works like a gun. So you just have to expose your have it in contact with your sample, and then that will give you instantly the value of your parameter.
Okay, ma'am. I think we're able to cover all the questions. So we'd like to thank you, ma'am, for sharing with us your knowledge with regards to the application of NIR spectroscopy. And I would also like to acknowledge the efforts of the Dean's Office headed by our OIC Dean, Dr. Myra Borines, and all who contributed for making this CEAT webinar series possible. With the participants, we are about 33 participants here who joined. Thank you very much. And before we end this, I would like to encourage everyone to please open or enable your video for picture taking. Okay. For the first page, smile. Okay. For the second page, smile. Okay. For that's first and second page only. All right. That would be all. Thank you and have a nice day.
Thank you.
Thank you, Ma'am Joanne. Thanks, Engineer Flores, and thanks, Sir Luyon.
Thank you,
Maraming
sir.
salamat po sa pag-attend.
Thank you, RC. Thank you, Joanne, and of course, Fide. Congratulations.